Hello and welcome to our SOL review of 8.4b properties. Now, little help, this is actually going to be 8.4b and 8.5b because the properties are actually used in the same situation in both cases. One is for equations and the other is for inequalities. Now, we have some basic properties we need to talk about first, which are the field properties. And some of these you've heard already, such as the associative property and the commutative property. Associative property you can always think of as the parenthesis one. Who do you associate with? Who are your friends? So they're grouped together a certain way, and it works for addition and multiplication. Notice how subtraction and division are actually left off. That's because none of these properties actually apply for those two operations. We also have what's called the identity. Now, the identity doesn't actually change anything. Hence why it's called an identity. So if you look in our problem, we have, for addition, it's adding 0. Well, adding 0 doesn't change the problem, hence why we end up with A. So you can think of identity as not changing. Now, for multiplication, the identity is 1. And again, identity doesn't change. Inverse, you could really think of as the opposite. So whatever is happening to the operation, it does the opposite. So if you notice we had positive A, well, now we're going to have negative A, and it cancels it out. So we end up with 0 for addition. Now for the multiplication one, since we had A, we're actually going to basically divide A, or multiply it by 1 over A. Same concept. And we end up with 1. If you notice, for addition, when we did the inverse, we ended up with the identity. And when we did multiplication, we also ended up with the identity. That's because when you cancel something out, you're left with the identity. The other one we know is the distributive property. It might help a little bit better if I draw the arrows that we're so used to seeing with this property. But if you notice, A gets shared with both B and C. So this also holds true. Now, there's a couple new properties we do need to talk about, such as the multiplicative property of 0. This is a very easy one. Anything you multiply by 0 equals, you guessed it, 0. Not too bad. The zero product property, which means when you multiply two numbers together and you get 0, one of them had to be 0 in order for that to happen. We also have three other properties that kind of get introduced in this section, which would be the reflexive, symmetric, and transitive. Now, the reflexive you could think of as a reflection. When you look at it, you see what you see. That's exactly what it is. So whenever I have A, I get A. Check that out. Symmetric is when you have something and it's kind of mirrored back in a certain way. So, if A equals B, well then flip it around. B equals A. They're symmetric, kind of like butterfly wings. And the transitive property says, hey, if A equals B, B equals C, then A equals C. A good example of the transitive property would be something like 1 plus 2. Well, that's equal to 4 minus 1, which is also just equal to 3. So all three of those are the same thing. It's just kind of saying, hey, if A equals B and B equals C, well then 1 plus 2 better equal 3. All right, there's also four equation and inequality properties that are introduced in this section, which is addition, subtraction, multiplication, and division. Now, what these are, these properties of equalities and inequalities, if you notice it's a little different on the right column when we talked about it. But what these properties are is when you're trying to solve an equation or inequality, these are the properties that say, hey, if you do it to one side, you need to do it to the other. So for instance, if we were going to add something to one side, maybe like a 4 or a negative 2, well then we're also doing it to the other side. So these four properties here, that's what they're saying, is if you're going to be doing something to one side of an equation or inequality, you must remain balanced. The last one is just substitution, which just says if you're going to replace something, they better be equal. Now, let's go ahead and take a look at an example problem. By the way, before I move this off, one good idea for the video is to actually go back and I would pause it for 5 seconds on each screen and just kind of look through and really try to understand these properties a little bit more in depth. I think it's going to be really helpful when you go and try to apply these problems. Just pause the video, look at them for a solid minute or two, and then hit play again. So I would pause it there, and I would pause it here as well. Okay, let's take a look at an example problem. So, Pierre solved an inequality as shown. Which property justifies the step between 3 and 4? So our big focus is right there. We care what happened from there to there. So if you notice, we had plus 0, and then we just ended up with n. Adding 0 doesn't do anything. That's the identity. So the answer to this problem would be B. But just for fun, I want to go ahead and step through the other steps as well. So when you go from step 1 to step 2, if you notice, on both sides we added -3. Well, since we added to both sides, that would be the addition property of equality. So we'll call that prop of equality. Oh, wait, is it equality? No. You got to be careful with the phrasing of these sometimes. So if you look, I should not have drawn an equal sign. I actually should have done an inequality. So we should call this the property of inequality. It's easy to make those little mistakes sometimes. Let's go ahead and take a look now from step 2 to step 3. So from step 2 to step 3, it looks like over here we just cleaned up the math, but ooh, we went from 3 plus -3 to 0. That would be the additive, because we added inverse. So actually, they put, this is a problem A, or the answer A, I should say, from there, and they tried to sneak it in there just to see if you were paying attention. And in fact, this one was answer C, and answer D didn't show up. Thanks for watching.